digital footprint is a trail of data you create while using the internet. It includes the website you visit, emails you send, and information you submit to online services. A passive digital footprint is a data trail you unintentionally leave online. For example, when you visit a website, the web server may log your IP address, which identifies your internet service provider and your approximate location, while your IP address may change and does not include any personal information. It is still considered part of your digital footprint. A more personal aspect of your passive digital footprint is your search history, which is saved by some search engines while you are logged in. An active digital footprint includes data that you intentionally submit online. Sending an email contributes to your active digital footprint, since you expect the data to be seen and or saved by another person. The more email you send, the more your digital footprint grows. Example of digital footprint. Example number 1. When you comment on a post in social media. Example number 2. When you tweet on Twitter. Publishing a blog and posting social media updates are another popular way to expand your digital footprint. Every tweet you post on Twitter, every status update you publish on Facebook, and every photo you share on Instagram contributes to your digital footprint. The more you spend time on social networking websites, the larger your digital footprint will be. Even liking a page or Facebook post adds to your digital footprints, since the data is saved on Facebook servers. Everyone who uses the internet has a digital footprint, so it is not something to be worried about. However, it is wise to consider what trail of data you are leaving behind. For example, remembering your digital footprint may prevent you from sending a scratching email, since the message might remain online forever. Data fusion is the process of integrating multiple data sources to produce more consistent, accurate, and useful information than that provided by any individual data source. Data fusion processes are often categorized as low, intermediate, or high depending on the processing stage at which fusion takes place. Low-level data fusion combines several sources of raw data to produce new real data. Expectation is that fused data is more informative and synthetic than the original inputs. For example, sensor fusion is also known as multi-sensor data fusion and is a subset of information fusion. Humans are a prime example of data fusion. As humans, we rely heavily on our senses, such as our vision, smell, taste, voice, and physical movement. A combination of all these senses combines on a daily basis to help us in performing most, if not all, tasks in our day-to-day lives. That in it itself is a prime example of data fusion. We rely on a fusion of smelling, tasting, and touching food to ensure it is edible or not. Similarly, we rely on our sight and our ability to hear and control movement of our body to walk or drive and perform most tasks in our lives. In all these cases, the brain performs the fusion processing and control what we need to do next. Our brain relies on a fusion of data gathered.
Is about real-time big data. Real-time big data is a process of transferring information to the servers in real time. It is often used in business cases to gain competitive advantage against other business rivals. A good example for this is online shopping. Whenever a consumer creates an account in its website, its basic information like name, age, sex, and locations are directly connected to the servers. The consumer searches for the item that he needs. The system automatically analyzes the item that he needs and make a suggestion searches for the consumer to look at. For some cases that the consumer never really buys the product that they look at, they just leave it at the cart. In that case, the system analyzes the consumer's profile, then gives the consumer a coupon for him to purchase the product that was left in its cart. That's how real-time big data helps in terms of competitive advantage in businesses.
What is big data and machine learning? Things you need to know. Basics. What is big data? Big data, it's relatively simple. It refers to extra large amounts of data that require specializedly and solutions in order to be gathered, like analyzed and implemented data. Business operation. Machine learning algorithms are applied to increase efficiently insightfulness of this data. The big data changing the ways we work and live, even think. This kind of data requires a lot of power and specifically mechanism to handle it. 4 V's of big data. Number 1, volume, the amount of data. Number 2, velocity, the speed of processing data. Number 3, variety, the kinds of data you can collect and process. Number 4, veracity, quality and consistency of data. Everything is data, is one or another, but you have to understand what data is useful for. Your particularly business, operation, or purpose, and what can be discreated. Overall, there are 2 types of gathered data. Data submitted intentionally. This type of data includes like when the user creates an account of the website, subscribe to an email newsletter, or perform 2 payments, for example. Number 2, data as byproduct of other activity. All that can be processed and put in a certain context. There are generally interaction with an ad content or ads like YouTube videos. Where does the data came from? Collect straight from your resources, first party. Brought in by your partners, second party. Bought from the third party, yung data mining like data analytics are right in the very heart of big data. Solutions, data minings or stands for collecting data for various success or sources, while data analytics is making senses of sorted analyzed data can be uncover hidden patterns like incredible business value for every industry. Basics. What is machine learning or ML? The term machine learning can be defined as system of automated data processing and decision making algorithms designed to improve their operation according to the results of work. Basically means like learning on the go. In the realm of big data, machine learning is the used to keep up the ever-growing and ever-changing stream of data and deliver continuously evolving and valuable insights. Machine learning algorithms are used to be labeled, like define what it is or the incoming data and recognize patterns in it, which are subsequently translated into the valuable insights that can be further implemented business operation. After that, the algorithms also use that automate certain aspects of the decision making process. So we have very basic flow of data processing, like once comes in various sources. Machine learning algorithms label like statisticals look for patterns. Data is translated into unsensible insights. Insights are implemented into the business operation. And lastly, business and learning processes are automated. Machine learning algorithms can be applied to every element of big data operation, including data labeling, data analytics, descriptive, diagnostic, predictive, prescriptive, planning, lastly, scenario simulation. So the difference of big data and machine learning, big data analytics pulls from existing information to look for emergency patterns that can help shape our decision making processes. And the machine learning, on other hand, machine learning can learn from the existent data and provide the foundation required for a machine to teach itself. That was machine learning. So, the third pattern recognition, big data analytics can reveal some patterns through classification and sequence of analytics. So, the machine learning in pattern recognition, he helps that learn from the collected data. He helps the collected data from machine learning takes this concept in a one step that a big by using data. Data volume, big data as the Tages tends to be interested in large scale data where the problem is detailing with the large volume of data. So data volume, machine learning tends to be more interested in small data sets like where over earphones like that speaker fitting in the problem.